this one, then we will go for the next part, second part, that is sampling theory. Okay. And see here, this problem states that if a coin is tossed thrice, the random variables x and y are defined as follows. So this and all I have explained in the previous session. So x is equal to 0 or 1 according as head or tail occurs on the first toss. So x will take only two values, 0 or 1. So when it will take 0 means if in the first toss head appears. Okay, so then x value will be 0. So when it will take 1, if in the first toss tail appears, then x will take the value 1. Okay, and y is the number of heads, right? So using this data, we need to determine the distributions of x and y. Again, joint distribution of x and y. And again, expectation of x, y, expectation of x, y, and standard deviations of x, y, covariance and correlation. Okay, so this also I have explained it since. So what is this S? S is your sample space. So these are the 8 possibilities you will have. Okay, so here all heads, here first 2 heads, then the third one is tail like that. So now see here, since in the first 4 cases, in the first task we are getting head, so therefore x is taking all 0 values. Okay, so again in the remaining last 4 cases, tail is there in the first case, first toss, so therefore x will take the value 1, right? So now here you count the number of heads and right because y is the number of heads. Here the number of heads is 3, here it is 2, here 2, etc. Okay. So now first let us find the probability distribution of x and y. Okay. So what is this probability means? Probability of x is having 0. X is having 0 means see here there are 4 cases out of 8 cases. So therefore it is 4 by 8. It is equal to 1 by 2. Similarly, this will happen for x is equal to 1. So x is equal to 1. Probability of getting x is equal to 1 is also 1 by 2. But here y will be taking 4 values. See here y is having the value 0, 1, 2, 3. So therefore y values will be 0, 1, 2, 3. So probability of having y as 0 is, see here, there is only one case where y is 0 out of 8 cases. So therefore it is 1 by 8 probability it is. Similarly, probability of y having 1 is 3 by 8. Y is 2 is again 3 by 8. And y is 3 is 1 by 8. These are the probability distributions of x and y. So these corresponds your f values and g values. Okay. So marginal distribution. So therefore f of x is given by 1 by 2, 1 by 2, and g of y are given by 1 by 8, 3 by 8, 3 by 8, and 1 by 8. Okay. So now in the second sub question, we will go for finding Jij values. Jij values means joint distribution of x and y. So here, in order to find these values, we need to look both values x and y. So this term corresponds to, this is your J11, this corresponds to probability of x is having 0 and y is having 0. So you can check out here in this table. So whether you are having x 0 and y 0 in one case, you are not having any case where x is 0 and y is also 0. So therefore, this number is, this probability is 0. There exists no case where x is also 0 and y is also 0. So therefore, it is 0 out of 8. So therefore, J11 value is 0. Did you understand how I got this as 0? You have any doubts in this?
No.
Okay, so yes, here, see this number. How to get this number means x is 0 and y is 1. You can check here. X is 0, y is 1. See here, I am having one case. X is 0 and y is 1 out of 8 cases. So therefore, J12 value is 1 by 2. See here, sorry, 1 by 8. J12 value is 1 by 8. Similarly, this number, how you will get means this J13 is x is 0 and y is 2. See, x is 0 and y is 2. We are having two cases. So therefore, it is 2 by 8. 2 by 8 is nothing but 1 by 4. Similarly, 0, 3. So 0, 3 means there is one case. So therefore, it is 1 by 8. Okay. Similarly, the second row, how we will get means x is 1, y is 0. X is 1, Y is 0 means again I'm having 1 case, so 1 by 8. Again X is 1, Y is 1. See here we are having 2 cases, so 2 by 8 it is 1 by 4. Again X is 1, Y is 2. So X is 1, Y is 2 means there is only 1 case, so therefore it is 1 by 8. See this one, right? Again X is 1 and Y is 3. So there exists no case such that X is 1 and Y is 3. Okay, so therefore this probability is also 0. So now we have got these F values, probability of X, again these G values, probability of Y values, again joint distribution, okay, Jij values, right? So now we will go for finding these expectations, standard deviations, covariance and correlation. So these formulae already I have explained in the previous session. So expectation of X is given by summation X into F of X. So X is nothing but, X values are nothing but 0, 1 and these are F values. So therefore E of X is given by 0 into half plus 1 into half. Okay, that will give you 1 by 2. Again E of Y. So these are your Y values. Sorry, these are your Y values. You see, these are your Y values and these are G values. Therefore, E of Y is given by 0 into 1 by 8 plus 1 into 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8. That will give you 3 by 2. So I got expectation of X, expectation of Y. So now expectation of X and Y is given by summation X into Y into J. Okay. So these are X values, these are Y values, and these are Jij values. So therefore, see here, it is given by 0 into 0 into 0 plus 0 into 1 into 1 by 8 plus 0 into 2 into 1 by 4 plus 0 into 3 into 1 by 8. Okay, again plus same thing you do with the second row. So I have written everything here. So on calculation, you will be getting 1 by 2. Right, so now sigma x square, standard deviation of X and Y formula is given by, this is your variance. Sigma x square is equal to E of X square minus E of X whole square. Similarly, in terms of Y, so first you calculate the Z of X square, that is given by summation X square into F of X. So this term is not there, I am having only E of X. So E of X square, again you need to calculate. So E of X square formula is this summation X square into F of X. So therefore it is same thing again, you just do squaring for these numbers. So 0 square is 0, again into 1 by 2 plus 1 square is also 1 into 1 by 2. So this will be as equal to E of X, right? Similarly, you find E of Y square and substitute in these formulae, you will be getting your sigma X square 1 by 4, sigma Y square 3 by 4. So therefore, standard deviations of X and Y are given by 1 by 2 and root of 3 by 2. Okay. So now this is covariance. Covariance of XY is given by E of XY minus E of X into E of Y. So you substitute all the values, you will be getting this covariance as minus 1 by 4 and correlation is minus 1 by root 3. Again, I'm having all these values, you just substitute into the formula, you will get. Okay, so these are problems on joint probability distributions. I have discussed like each kind of problem. So if you are having any book, you can solve some more problems on this. Okay. Otherwise, I will send some material. You can go through those problems. Okay. You have any doubts in this joint probability? Ask me now. Otherwise, I will go to the next part.
No,
That is something clear. Okay. So yes. So this is the second part in the fifth module. Okay, so first part is joint probability distribution that we have already discussed. Okay, so what is the sampling theory? Suppose we want to study a huge population, okay, which contains a large data. But practically it is not possible to study each and every individual. Okay, so in that case, what we will do, we will consider a comparatively small sample. Okay, then we will study that sample and we will study the properties and apply the same properties to the entire population. Okay, so this is what sampling theory means, right? So sampling theory basically is involved with the collection, analysis and interpretation of data, right? So here we will come across the statistical inference. So what is the statistical inference means? The process of drawing some valid and reasonable conclusion about the entire population is called statistical inference, right? So what is this population? What is the meaning of population? Means a large collection of individuals or numerical data can be termed as either the population or universe. Okay. So in that, again, what is a sample? Sample means a finite subset of the population is called a sample, and the number of individuals present in the sample, we will denote it by small n. Okay, this is termed as a sample size, right? So after this, what is the sampling distribution? So what is the sampling distribution means? Sampling distribution is nothing but a frequency distribution generated by the characteristics of different groups. Okay, so that is frequency distribution, we call it as sampling distribution. See, in order to learn these sampling distributions, we need to learn some basic definitions. Okay, so let us learn those basic definitions. So first one is hypothesis. Okay, what is a hypothesis means? Hypothesis is an assumption. Okay, any assumption. That assumption may be true or false, right? So making a certain assumption to arrive at a decision is called an hypothesis. So hypothesis basically means an assumption, and this assumption may be true or may be false. Okay, for our convenience, we will make some assumptions. So those assumptions we call it as hypothesis. Okay, so here we'll come across one hypothesis that is called null hypothesis. So it is denoted by H naught. So what does this null hypothesis means? The hypothesis formulated for the purpose of its rejection, okay, is called a null hypothesis. Okay, we know that this is false and we will surely reject the hypothesis. Okay, so the hypothesis formulated for the purpose of its rejection is called a null hypothesis. So we will denote this hypothesis by H naught. Okay, in the problems you may make use of this null hypothesis. So we know that null hypothesis means it is always false, and we will formulate this only in order to reject this hypothesis. Okay, so that hypothesis is called null hypothesis. So here there are two types of errors. See here, which are those two types of errors means type 1 error and type 2 error. So what does the type 1 error means? See here, rejecting the true hypothesis. Rejecting the true hypothesis is mentioned as type 1 error. This is an error because we are rejecting the true hypothesis. There is an error. So this kind of error we call it as type 1 error. So what is type 1 error? Rejecting the true hypothesis is mentioned as type 1 error. Then what is type 2 error means? Accepting the false hypothesis. See here, accepting the false hypothesis is mentioned as type 2 error. So what are type 1 error and type 2 error? Rejecting the true hypothesis is called type 1 error, and accepting the false hypothesis is called type 2 error. Okay. So now we'll discuss about significance level. So what does this significance level mean? This is nothing but a probability level. Okay, the probability level below which leads to the rejection of the hypothesis. Okay, is known as significance level. So here we are discussing about two types of significance level. One is 5% significance level. One more is 1% significance level. Okay, we'll see what are these 5% and 1% significance level. So what is the significance level? Basically it is nothing but a probability level below which leads to the rejection of the hypothesis, right? So now, let's see here. Test of significance and confidence intervals. See if mean is mu and standard deviation is sigma for a normal population and x bar is the sample mean, then this term is called standard normal variate and is given by x minus mu into root of n divided by sigma. Okay, what is this test of significance mean? This is the process. The process which helps us to decide about the acceptance or rejection of the hypothesis. Okay, this process is called test of significance. So here also we will be using those two test levels of significance. One is 5% and another one is 1% level of significance. Okay, and this is your standard normal variate. It is given by t is equal to x minus mu into root of n divided by sigma. See here, if you consider a normal distribution table, you can find in the Google. If you want, you can see it. If you see that normal distribution table, see here 95% of the area lies between, see this, minus 1.96 to 1.96. Okay. So therefore, see here 95% of the area lies between minus 1.96 to 1.96. So therefore, I can write t lies between minus 1.96 to plus 1.96. So here you substitute your t value and you send this sigma root n and x this side, x bar. So therefore, you will be getting an expression like this. Okay, so this is called 95% confidence interval or significance level. Right. Similarly, you can also observe that 99% of the area lies between minus 2.58 and plus 2.58. Okay, here 95% of the area lies between these two numbers, and here 99% of the area lies between these two numbers, that is minus 2.58 and 2.58. So therefore, if you substitute that standard normal variate and do the multiplication, you will be getting this expression, and this represents 99% confidence level. Okay, so therefore this represents 95% confidence level and this represents 99% confidence level. So how we got this? Because using this normal distribution table. Okay, so here these two numbers corresponds to 95% of the area. 95% of the area lies between these two numbers, and here 99% of the area lies between these two numbers. Okay. So now, here, see this denotes the binomial distribution frequency samples. Okay. So this also we know, by binomial distribution, mu is given by n into p and standard deviation is given by root of n into p into q. So therefore, z, we know in the normal distribution z value is x minus mu divided by sigma. So if you substitute this mu and sigma values, you will be getting your z value as x minus np divided by root of npq, right? So if you find this mean proportion of success and standard deviation proportion of success, then that will give you here np divided by n means p and root of npq divided by n as equal to root of pq divided by n. So this is called, so these are called probable limits for z. Okay. So these are probable limits for z. See, these are the conclusions. So you should understand that in the problem, if you get your z value, z is what? Z is this, x minus mu divided by sigma. Mu is nothing but n into p. Sigma is nothing but root of npq. So in the problem, if you are getting your z value as less than 1.96, okay, then your conclusion is the difference between the observed and expected number of successes is not significant because this is less than 1.96. Okay, so therefore your hypothesis is correct. Okay, so with what percent of confidence level you can say that the hypothesis correct means with 95% of confidence level. Okay, you can say the hypothesis is correct. Hypothesis is true. Okay, or you can say with 5% level of significance, the hypothesis is true, right? But if your Z is greater than 1.96, then you can say the difference is significant at 5% level of significance. So therefore, the hypothesis can be rejected. Okay, if it is less than, the hypothesis is accepted. If it is greater than 1.96, then the difference is significant. Then the hypothesis is rejected. Okay, with 95% confidence level, or you can say at 5% level of significance. Okay, so this is about 95% or 5%. So if this is the number you should use for 1% level of significance or 99% of confidence level. Okay, so if Z is greater than 2.58, okay, your difference is highly significant. So you can reject the hypothesis at 1% level of significance. So in this case, when you can accept the hypothesis, tell me what should happen if you want to accept the hypothesis. In case of 2.58, it should be less. Okay, if Z is less than 2.58, then you can say difference is not significant. Okay, so therefore, at 1% level of significance, we can accept the hypothesis. So the conclusion is if Z is less than these two numbers, 1.96 and 2.58, always you can accept the hypothesis. Okay, at different levels of significance. In the first case, it is 5% level of significance. In the second case, it is 1% level of significance. Okay, so if Z is greater than these two numbers, then you can say the difference is significant. So therefore, you can reject the hypothesis at 5% level of significance and at 1% level of significance. Did you understand these things? Do you have any doubts? Ask your doubts, dear. Do you have any doubts?
No, ma'am.
Did you understand?
Yes, ma'am.
Okay. So now we'll go for solving some problems. Okay, using these things. See here, a coin is tossed 1,000 times and it turns a head 540 times. Okay, so decide whether the coin is unbiased. Here the hypothesis is the coin is unbiased. Okay, that's how mentioned in the problem. We need to tell whether the hypothesis is true or not. Okay, what is the hypothesis here? The hypothesis is the coin is unbiased, means it is a fair coin. Okay. So how to solve this means let us assume that the coin is unbiased. So therefore the hypothesis is what? The hypothesis is the coin is unbiased. This is the hypothesis. Now let us calculate the terms of this Z expression. So I want to calculate Z means I want this N, P, Q and X. Okay. So P is what? P is probability of getting head in one toss. Okay, so in one toss there will be two probabilities. Okay, either you may get head or you may get tail. So therefore, probability of getting a head, obviously it will be 1/2. Similarly, the probability of getting a tail is also 1/2. So therefore, P you can write it as 1/2 and Q as equal to 1/2. Okay, so using this data, the expected number of heads in 1,000 tosses is given by N into P. Okay, so N into P, N is 1,000, P is 1/2, so therefore you can always expect 500 heads in 1,000 tosses. Okay, so this is the expected number of heads in 1,000 tosses using this these values N and P. Okay, so this is your N into P product. Okay, so now, but in the problem, what they have given, the number of heads turned out is 540. Okay, you should take this as X. So X is 540 and we have calculated N into P, right? And also I'm having Q, so therefore you can calculate this root of NPQ also. Okay, so you write this expression that is equal to X minus NP divided by root of NPQ. So therefore you will be getting the value of Z as 2.53. Okay. So this 2.53, now you can check out. See, this 2.53 is less than this number 2.58. So therefore, what is our conclusion? The difference is not significant. Okay, since the difference is not significant, we can accept the hypothesis that the coin is unbiased. Okay, at 1% level of significance. Or with 99% of confidence level, we can accept the hypothesis that the coin is unbiased. Okay, you have any doubts in this problem? Ask. You have any doubts?
No, ma'am.
Okay, right. We'll go for the next one. See here, a survey was conducted in one locality of 2000 families by selecting a sample size of 800. It was revealed that 180 families were illiterates. Find the probable limits of the illiterate families in a population of 2000. Okay, so while explaining previously, we got this probable limits expression. See here. This is your probable limits expression. Okay, so in this problem, since they've asked to find the probable limits, I will be using this formula. Okay, this expression. So here, you write down the same thing. So we have this probable limits as p plus or minus 2.58 into root of pq by n. So in order to calculate this, I want p, q and n. Okay, n means sample size. So here the sample size is 800. Okay, so then what is this p? This p represents the probability of illiterate families. So probability of illiterate families means, so how many illiterate families are there? 180 illiterate families are there out of 800. So therefore p is given by 0.225. Okay, so from this you can calculate the value of q. So q is 1 minus p. So therefore this you will get it as 0.775. Okay, so now I got the value of p, q and n is nothing but 800. Okay, so now you put this expression. Probability limits of illiterate families is given by p plus or minus 2.58 into this. So now you substitute. So you will be getting, since you're having plus or minus, you will be having two numbers. Okay, 0.187 and 0.263. So therefore, the probable limits of illiterate families in a sample of 2000 is given by, see here, you just multiply. These are nothing but the probabilities. Okay, so now we are calculating the number. So 0.187 into 2000, similarly 0.263 into 2000. So therefore, the probable limits of illiterate families will be from 374 to 526 families. Okay, do you have any doubts in this? So we need to apply this expression for finding the probable limits. Okay, so this formula you need to remember. Yeah.
Ma'am,
Yes, tell me.
we did the probable limits for 800 families, no, ma'am, in the upper one.
No.
Here,
It
for
is
800
already
families.
given. It is already given. 180 families are illiterates.
Yeah,
Okay,
ma'am,
out of
but then
eight.
for calculating for 2000 families, we have to do 2000 by 800, no, ma'am.
2000 by 800. How come? For calculating which term you are telling?
Ma'am, here you found out the probability limits for 800 families, no, ma'am, out of 2000 families.
No. Out of 2000 only I found out. See, this P you are telling. You are telling this P, yeah?
Below on probability limits, ma'am.
Here.
Here we found out for n value equal to 800. So for 800
Yes.
families, we found out the probability limits.
No, not like that, dear. See, this is not like that. Here, n is sample size. Out of 2000, we have taken n as 800.
Okay, ma'am.
Okay. So now here, see here, we are getting out of 2000. Here we are getting for 2000. Okay,
Okay.
here you cannot put as 2000. Here it is 800. It is correct. Okay,
Okay, ma'am.
so using this, here we are finding out. Out of 2000, using this probability, here we are getting out of 2000, what are the numbers?
Okay.
Understood?
Okay, ma'am.
Okay, so we'll go for the next one. See here. A die was thrown 9,000 times and a throw of 5 or 6 was obtained 3,240 times. Okay. So on the assumption of random throwing, do the data indicate an unbiased die? Okay, here also the hypothesis is the die is unbiased. Okay, let us see whether this hypothesis is true or false. So first let us calculate the values of P and Q because we need P, Q, N, okay, in order to calculate Z. So what is your Z expression? Z is equal to X minus mu divided by root of NPQ. Okay, so X minus mu, mu means N into T, so divided by root of sigma, sigma is root of NPQ. So first let us calculate these values P and Q. So how to get this P means probability of getting either 5 or 6 is given by P of 5 plus P of 6. Okay. So in each case, the probability will be 1 by 6. Okay. In each case, you will be getting one time because only one 5 will be there. No. Similarly, there will be only one 6. So therefore, out of 6 cases, there is only one case. So 1 by 6 will be your P of 5 value and 1 by 6 will be P of 6 value. So therefore total probability is 1 by 3. So P value is 1 by 3. So Q is P minus, 1 minus P. So therefore Q value will be 2 by 3. And here N is what? N is 9,000. Okay. So here you write down, see N is 9,000, P is 1 by 3, Q is, it is 2 by 3. Okay. So N into P value is what? It is 3,000. Okay, we should get only 3,000 number of 5 and 6. Right? So, but here we are getting 3,240 times the values of 5 and 6. So this you take it as, this number you take it as X. Okay, this is the observed number. So therefore it is 3,240. So now you substitute in this expression X minus NP divided by root of NPQ. So your X value is 3,240, N into P is 3,000. The root of NPQ will be having like this 44.72. So therefore you are getting this Z standard normal variate as 5.4. Okay. So this number 5.4 is greater than this number 2.58. Okay. So therefore what is the conclusion? The difference between the observed and the expected value is highly significant. So therefore, we can reject the hypothesis at 1% level of significance, or with 99% of confidence level, we can reject the hypothesis. Therefore, the conclusion is the die is biased. Did you understand how to write the conclusion? You have any doubts in this? You have any doubts here in this?
No, ma'am.
Okay. See, we will discuss some more problems in the next session. Okay, so see what you have to do is, you have any textbooks with you people? No? See, tomorrow I will be posting one quiz in the Google Classroom. Okay, tomorrow. So I will fix one time. Okay, with up to that time, that quiz will be open. Okay, so within that time limit, you should do the quiz, answer the quiz, and you should submit in the Google Classroom. Okay, do that without missing. Right? Yes or no?
Okay,
Okay,
ma'am.
ma'am.
Okay, ma'am.
Okay, so this notes I will share, both joint probability notes and the sampling theory, what I have done up to this, I will be sharing in the Google Classroom. So just go through, you have any doubts, you can ask me in the next session. Okay, so that quiz tomorrow you do it. Okay, tomorrow I will upload, so I will inform in the WhatsApp also. Okay, so then you can do that. Okay, then I will be ending the meeting now. Okay, then bye-bye.